Alrighty guys, we are starting a brand new unit 10. We're going to be talking all about quadratic functions and their graphs and solving their equations and all kinds of fun stuff. So 10.1, the first thing we're going to do is we're going to look at parabolas and we're going to graph them and talk about the properties of them. And that might make no sense right now, but don't worry, it'll make a little more sense in a second. So let's everybody actually do this. So what we need to do is graph the function f of x equals x squared. And this is the only graph I'm going to make you draw in your notes, I promise, but you do need to draw it. So remember, if we don't know the shape of a function, it's been a while, but if we need to graph a function, we need to make a table, an input-output table. So I'm going to put my inputs on this side, my x's, and my outputs, my f of x's, on this side. And then what inputs should we always start with to try to get a good idea of the shape? Remember, we should do -3 all the way up to 3. And then to find my outputs, I'm going to actually input my input here. So I'm going to put my -3 here, and I'll get -3 squared, which is 9. All right, so now I'm going to plot each of these points. So I'm going to treat this one like the point -3, 9. So that goes across -3 up to 9. All right, now we could input more inputs. We could do -2.5, but I'm willing to bet that if I input -2.5, the output would be somewhere in between 4 and 9, probably somewhere like right around here, right? So we can go ahead and make that assumption and connect all of these points together and assume what goes on in between them. And it's probably going to continue upward as well. So here's our graph of f of x equals x squared. So do you remember what we call a graph that's shaped kind of like a U like this? Well, this is actually, and it's not exponential. It looks a little bit like an exponential, but because it goes back up on this side, this is called a parabola. So a parabola is the U-shaped curve you get when you graph a quadratic function. And if you need a reminder, quadratic means the degree is 2. So this is the standard form of a quadratic function. This is how we're going to see them written for a while. So a couple examples. Actually, that y equals x squared was an example of a standard form. The a was just 1, and then the rest of these were just zeros, but that still counts. Let's do one where we fill everything in. We could have y equals 4x squared plus, and let's put a 6 here, plus, I don't know, 11. All right, moving on. All right, so I made the background of this one purple. You don't need to write this down. But one thing that I noticed about these beautiful parabolas is just like how I said with it's not an exponential because it goes back up on this other side. It's symmetrical, right? So whatever it does on this side, it does the same thing on the other side. Same thing with this one. So it goes down on this side and it goes down on this side. It turns out that that is an important characteristic of a parabola. Parabolas are always symmetrical, and the line that divides them in half is going to be called the axis of symmetry. So go ahead and write this down as well. All right, so let's do some practice with this. So example 1 says graph the parabola using Desmos, identify its line of symmetry. So you're not going to need too much space to write your answers in, but go ahead and copy all these down. All right, and we're going to go ahead and we're going to do A together. So I'm going to head over to Desmos, and I'm going to type in my function. It was f of x equals x squared. If you don't remember how to get that squared, open up this keyboard down here. It's this button, type in a 2, and then hit the right key to get out of there. Minus 4x minus 5. All right, so I'm looking for the axis of symmetry. So I need the line that divides it in half, which looks like it's right here. And I see that that number is a 2. Now we need a line, though. How do we get a vertical line again? Well, remember that a vertical line was just x equals, and then you put the number. So, oh, I even can make it show up and confirm, yes, that is the line that cuts it in half. So x equals 2 is my axis of symmetry for this one. So for A, it's x equals 2. That's what we're doing for each of these. So take a second and pause the video and then go and try to finish the rest of these on your own. When you unpause it, I'll have the answers up here. All right, here are our answers. These are all of our axes of symmetry. One that maybe you might have struggled with is this one where you were supposed to get 4.5. So let me give you a little tip. So here I have it plugged in, typed in x squared minus 9x. I'm looking for the axis of symmetry, and I can see it's right about here. If you click on this point, it'll tell you the exact point, and that will be your midpoint, your symmetrical point. So I can see that it's 4.5, and so my line then is x equals 4.5. There we go. So something else that you may have noticed is that sometimes our parabolas are this shape, kind of like a U, but sometimes they're an upside down U. So here we saw two that we saw earlier. This one is regular, this one is upside down. I want you to kind of look at these two equations and see if you can figure out what makes this one upside down and this one not upside down. So let's look at two more. These are ones that we just saw before. So 8x squared is a regular U shape. This one is an upside down U shape. Do you have a guess as to what it is that makes it regular or upside down? All right, so it turns out that the thing that makes it upside down or not is whatever this first number is. If this first number is negative, it's going to be upside down. If it's positive, it's going to be regular. Same thing with these last ones. This one was negative, this one was positive. So that's how you tell, we're going to call that opening up or opening down. That's how you tell if a parabola opens upward or downward. Remember, A is just the first number. All right, there's one other term that we need to learn regarding parabolas today, and it's the word vertex. So the vertex is whatever the highest point or the lowest point is of a parabola. We're either going to call that vertex the minimum or the maximum, depending on if it's the lowest point or the highest point. All right, let's go ahead and do one last example. So they want us to graph the parabola on Desmos, find the vertex, and then state if it's a maximum or a minimum. So again, you're not going to need a ton of space, so go ahead and copy these down. And let's go ahead and let's do A together. F of x equals 6x squared. So I've got f of x equals 6x squared. All right, got to move up here. And this one, okay, so I need to find its vertex. So that's going to be, in this case, the lowest point. Click on it, and hey, it tells me it's 0, 0. And looking at this graph, is it a maximum or a minimum? Well, it's at the very bottom, so that must be the minimum. It's the lowest point. So this one is the point 0, 0, and it's a minimum. All right, that's what we're doing for each of these. Go ahead and pause the video, finish up the other four. When you unpause it, I'll have the answers up here for you. Here are our answers. Now there's one thing that I want to point out. We didn't need to go through all the work of graphing them to figure out if they were going to be a minimum or a maximum, because we just learned how to tell by looking at it if it's going to open upward or downward. So the ones that have negative coefficients, these two, those ones were going to open downward, right? They were going to be upside down. So these ones were both going to be this shape. And if that's the case, we know that it's going to have a peak. So these ones would have had maximums, and that's exactly what we got. The other ones all had positive coefficients, so those ones were going to be the regular U-shaped parabola, which means those were all going to have valleys, which means those three were going to have minimums, which is exactly what we see. All right, and then for now, all you need to do is just graph it and click on the vertex. You might need to zoom in or out, drag around the graph, but you need to find it like that. In our next section, we're going to learn how to find these without needing to use Desmos.